Namaste students. In this video we are going to study about the directive influence of NO2 group towards electrophilic substitution reaction in benzene. How the presence of NO2 group affect the electrophilic substitution reaction. Consider benzene to which attached an NO2 group. NO2 group can be written as N double bond O single bond O. This is nitrobenzene. When nitro group attached to benzene, what happens to the further substitution, further electrophilic substitution reaction? We know benzene ring, due to the presence of 6 pi electron, is electron rich. So this can be readily attacked by electrophiles, right? Electrophiles can come and attack benzene ring because it is electron rich. So electron seeking reagents come and attack benzene ring and give product. Now we are going to study when NO2 group is present in benzene, what happens to the electrophilic attack. Will the attack of electrophile take place more easily or it would become more difficult due to NO2 group? That we will discuss now. We know that this NO2 group I have written N single bond O. This arrow I have put an arrow mark. This bond I have put an arrow mark towards oxygen atom. This means that this is a special type of covalent bond called coordinate covalent bond. Here both of the electrons of this bond comes from nitrogen atom. Means both of the electron, both of the shared electron comes from nitrogen atom. That's why I have written an arrow in the bond. Now this N double bond O bond, oxygen more electronegative, so oxygen take the electron pair, making oxygen into negative and nitrogen into positive, right? So the nitrogen atom of NO2 group is electron deficient because nitrogen atom is positive. So due to this positive charge on nitrogen atom, NO2 group is an electron withdrawing group. Nitro group is an electron withdrawing group. Why is it electron withdrawing? Because nitrogen carry a positive charge. Nitrogen is electron deficient. So this is benzene ring. So this NO2 group when attached to this benzene ring, what happened? NO2 group withdraw the electron density from the benzene ring. Means from the benzene ring, electrons move towards the nitrogen atom. This nitrogen atom attract the electrons from the benzene ring. This effect is called inductive effect, minus inductive effect, negative inductive effect. The NO2 group is electron withdrawing due to negative inductive effect. It withdraws the electron density from the benzene ring. So what happens to the electron richness of benzene ring? NO2 group is withdrawing electrons from the benzene ring. That means electron richness of the benzene ring decreases. Clear? Electron density of the benzene ring decreases due to the presence of NO2 group because NO2 group is electron withdrawing group. So the attack of the electrophile will be difficult. If NO2 group present in benzene, the electrophile, it's difficult for the electrophile to attack the benzene because the electron density on the benzene ring is less if NO2 group is present because NO2 group withdraw the electrons from it. Or we can say NO2 group deactivate the benzene ring towards the attack of electrophile. Towards the attack of electrophile. Means it is difficult for the electrophile to attack because the benzene ring is less electron rich now if NO2 group is present. So we say NO2 group deactivate the benzene ring towards the attack of electrophile. Electrophilic substitution is difficult if NO2 group is present in benzene. Now in addition to this negative inductive effect, there is one more electron displacement effect in benzene due to NO2 group that we will explain now. In addition to inductive effect, there is one more electron displacement effect, that is resonance effect. The resonance effect is also means the positive charge and this pi bond, here lone pair electron, all these can be in conjugation with it, or all these can be in resonance with the benzene. We know benzene is a conjugated system. When NO2 group attached to benzene, which is a conjugated system, there can be delocalization of pi electrons of the benzene ring towards the nitrogen atom, towards the NO2 group. Means electron displacement from the benzene ring, from the conjugated system towards the substrate, here NO2 group, through resonance. Pi electrons of the benzene ring are in resonance with the NO2 group. Let us see how. So this structure, here the nitrogen is positive, N double bond O bond breaks, electron pair move towards more electron negative oxygen, oxygen becomes negative, this nitrogen is positive. So towards this nitrogen atom, one of the pi bond, this adjacent pi bond, the pi bond breaks and the pi electron move towards this positive nitrogen and they form a bond. So we get another structure, that is this structure of nitrobenzene is in resonance with this symbol indicate resonance. Resonance with another nitrobenzene structure in which these two pi bonds no change. This pi bond breaks, now this is single bond, and what happened here with the nitrogen? Here a double bond is formed with the nitrogen. This N double bond O becomes single bond, oxygen is negative. This one is coordinate covalent. And what happened to this carbon? Ortho carbon atom, this carbon atom lost its pair of electron. Both the electrons shared between these two carbon atoms now lost. So this carbon atom lost its electron. So this carbon atom becomes positive. Ortho carbon atom is positive in this structure. Clear? Now since the ortho carbon atom positive, the adjacent pi electron, pi bond we know very weak bond, loosely held, they are ready to move towards the positive carbon. So this adjacent pi bond breaks and this pi electron move towards the ortho carbon atom which is positive and form bond with it. So we get another resonance structure. This is in resonance with another nitrobenzene structure in which this pi bond has no change. Here this pi bond has broken and that pi electron now shared between these two carbon. Double bond N O minus, there is no change. But here this para carbon atom lost its shared electron. So this para carbon atom becomes positive. Now towards this positive carbon atom, further the adjacent pi electrons move, delocalization, move towards the positive carbon atom and form bond with it. So we got another resonance structure in which a new pi bond is formed here. And what happened to this carbon atom? This carbon atom lost its shared electrons. So this ortho carbon atom becomes positive. This pi bond has no change. Double bond N, single bond O minus O. Now see, again this ortho carbon atom is positive, So this pi electron shared between carbon and nitrogen now breaks and the electron move towards this ortho carbon atom and form bond with it. So what do we get? We get one more resonance structure. Here you can see, here a new pi bond is formed. Double bond N O minus O, single double bond. Means here in the last structure what happened? The pi electrons between carbon and nitrogen is given back to the benzene ring towards this positive carbon atom. So we get a structure similar to the first structure, right? If this is structure 1, structure 2, structure 3, 4, 5. So how many resonance structures do we get for nitrobenzene? There are 5 resonating structures we can draw. Here in these structures we can see there is movement of electron. Movement of pi electron from the benzene ring towards the nitrogen atom, towards the nitro group. This type of movement of electron between the conjugated system. Benzene is a conjugated system, we know, alternate single and double bond. From the conjugated system towards the substance. This is called resonance effect. This is called a negative resonance effect, minus R effect. In which direction? In the upward direction, right? Negative resonance effect act in the upward direction, means from the benzene ring towards the nitro group. So electron density due to minus R effect also, the electron density of the benzene ring is reduced. Nitro group is electron withdrawing due to the resonance effect and also inductive effect. Inductive effect also act in the same direction, no? Inductive effect also act in the same direction, minus I effect. Here this negative resonance effect also act in the same direction, upward direction, means from the benzene ring towards the NO2 group. This is an electron withdrawing group. It withdraws the electron density from the benzene ring due to minus R effect, negative resonance effect and negative inductive effect. Electron density of the benzene ring is reduced. Electron richness of the benzene ring is reduced. So the electrophilic attack will be difficult on benzene if NO2 group is present. Because the benzene ring has become less electron rich now. Clear? So NO2 group is called deactivating group. NO2 group is an example of ring deactivating group. NO2 group is called ring deactivating group. Why it is called a deactivating group? Because it deactivates the benzene ring towards the attack of electrophile. Electrophilic attack on nitrobenzene is difficult. Moreover, if the attack of electrophile takes place in benzene, it will direct the electrophile towards which position? For example, if nitrobenzene to undergo electrophilic substitution reaction. This is nitrobenzene. An electrophile come and attack benzene. So into which position nitro group direct this electrophile? This electrophile, here when you see the structures, resonance structures of nitrobenzene, we can see here in ortho position there is positive charge. In para position and in the other ortho position also there is positive charge, particularly electron deficient. So which is the more electron rich position in benzene? Out of ortho, meta and para, here in these resonance structures, none of the resonance structures contain a positive charge in meta. But in ortho and para position, we can see positive charge. That means ortho and para positions are more electron deficient. Compared to ortho para, meta position is electron rich. So this NO2 group directs the incoming electrophile towards the more electron rich meta position. So this electrophile will be directed towards NO2 group, say come and attack this meta position because meta is comparatively more electron rich. Ortho and para positions carry positive charge due to resonance. So the comparatively more electron rich position is meta. So the electrophile is directed towards meta position. So what do we get the product? The product obtained will be meta substituted nitrobenzene. Nitrobenzene direct the electrophile towards meta. So meta position the hydrogen will be substituted by electrophile. We get meta substituted product will be obtained. That means nitro group is a meta directing. Clear? NO2 group is an electron withdrawing group. it deactivates the benzene, so it is a deactivating group, ring deactivating group, and also meta directing group.